Hello and welcome to my channel. In this video, I'm going to show you how you can configure hierarchical route reflectors, and of course I'm going to speak about the benefits and disadvantages of running hierarchical route reflectors in your network. So first of all, let me just explain the topology that we are working on. In this topology, as you can see, there are two different autonomous systems. One of them is AS100 on the left, and I'm going to start the configuration on here. What we have in this autonomous system, as a matter of fact, is 7 different routers. And if I just go with the normal configuration, based on BGP rules, what is going to happen. All the prefixes that I send from autonomous system 200 to here is going to get to R1 and R3, and of course they are going to advertise it to different routers. Let's say that router 1 is going to advertise it to router 2 because that's an eBGP route, and based on rules, a router would send eBGP routes to every eBGP or IBGP peer. Router 2 has received these prefixes from router 1, which is an IBGP, so it's not going to send it to any other IBGP router. So what I need here is I can configure confederation in the whole AS, or I can just go with route reflection. What I'm going to do is to configure this as route reflector. Now, when we have lots of routers in our network, of course the number of routers for me is not too much, but let's say that we have 20 routers in our area. So what I'm going to do in this situation, just to reduce the number of sessions that route reflector is going to have, I need to go with hierarchical route reflector design here. Now, there are other benefits for this as well, but the most important one, of course, is going to be the reducing of the resources that route reflector needs, because it doesn't have to have so many sessions in the network. But the drawback is we are going to have somehow suboptimal routes, which is going to cause problems for our network. But let's just check the configuration here, and after that we are going to examine to see what is going to happen. In this configuration, router 2 and router 5 are going to be route reflector. They are going to be in a cluster. I'm going to configure them in cluster 25, 25, 25, 25. And they are going to have router 1, router 3, router 4, and router 7 as route reflector client. Now, router 1 and router 3 in the first look do not look to be do not need to be route reflector client, but let's say that the prefixes that are 6 sends, what happens to them? If router 6 sends some prefixes, so what is going to happen? Because they are non-client, router 5 is not going to send the prefixes to R3 and R1, and on this side AS200 is not going to receive anything from them. So I have to configure them as clients to router 2 and router 5. On the other hand, I'm going to configure router 4 and router 7 as route reflector client, and I'm going to configure them in cluster 47. The only client that they are going to have is going to be router 6, and this way we are going to see what is going to happen to router 6 and how it is going to be able to reach to other parts of the network. And then we are going to examine the number of sessions and everything on these route reflectors. Right now this is a greenfield area. I have not configured anything, so what I'm going to do is to go to router 2 and router 5. I can start configuring with peer group or with template, whatever that you wish. But let's just start this. Configuration on AS200 is done, and AS200 has BGP AS200 running. R10 is a route reflector, so whatever R8 receives, router 9 is going to receive it as well. So let's start the configuration. I have already configured AS200. R10 is a route reflector for router 8 and 9, which means that anything that router 8 receives will be received by router 9 as well. So let's go to router 1 and start the configuration. We have adjacencies with router 8, 2, and 5. So I'm on router 1. I'm going to start this. Router BGP 100. No BGP default IPv4. I always do this, of course, just because I work on multiple platforms, and on all of them almost address family IPv4 is by default disabled. No address family is enabled by default. So I just want to be uniform. So this is what I do all the time. I'm going to say neighbor 10, 10, 18, 8 is in remote AES 100 or 200 actually. Then I'm going to have neighbor 2222 in remote AES 100 with an update source of loopback 0. And also neighbor 5555 in remote AES 100 with an update source of loopback 0. So that is my configuration here under address family IPv4 unicast. Now I need to activate each one of them. So this one should be activated. This one should be activated. And this one should be activated. Okay, so let's advertise network 1111 into BGP as well. Okay, and then save the configuration. Let's go to router 3, do the same configuration on router 3. So I would say do show run, not do show run, just show run. Section router BGP. Part of the configuration is going to be similar to this. So I have these neighbors and this one. So I'm going to move this to router 3. So, and router 3 of course is neighbor with 10, 10, 39, 9, which is in remote AES 200. Under address family IPv4 unicast, I need to activate this one, I need to activate this one, and I need to activate this one. So end and WR. Okay, so this neighbor is up. So far we have just configured this part. So let's go to router 2 and router 5. Now, because router 2 has 1, 2, 3, and 4 neighbors, I can go with the peer group, or I can just go with the simple configuration. Peer group is going to be easier, or I can create a template, whichever you would like, you can do it. So let's go to router 2. Going to router 2, router BGP 100, no BGP default IPv4. Okay, so I'm going to say neighbor clients is going to be peer group, neighbor of course. So neighbor clients is going to be peer group. This neighbor is in remote AES 100. This neighbor has update source of loopback 0. And I'm going to say neighbor 1111 is under peer group clients. Neighbor 3333 is going to be under this. And also neighbor 4444 and 7777 are going to be part of this. 7777. So we have 1, 3, 4, and 7. So 1, 3, 4, and 7 are going to be clients of router 2. Okay. So let's go under address family IPv4 unicast. I'm going to say neighbor clients are going to be route reflector clients. Okay. And now I need to activate these one by one. On some of the platforms I can just say neighbor clients activate, but here On regular IS, I have to activate these neighbors one by one. So this one, 4 and 7 as well, and this one. Okay, now that I have activated this, let's advertise 2222 with a mask of 32-bit into BGP. Okay, so and save the configuration. I'm going to configure router 5 as well. Now one thing that I didn't do is I did not configure the cluster ID. I'm going to do this. Let's do that. So let's go to configuration mode, go back to router BGP 100. I'm going to say BGP cluster ID is 25 25 25 25 and save it. So I'm going to say show run section router BGP, because most of the configuration is quite simple, similar to what we are going to have on router 5. So I'm going to just copy these. All of them are going to be clients for router 5 as well. So I'm going to copy all of this and go to router 5, en configuration terminal, and this part is totally similar. And under address family IPv4 unicast, again some parts are going to be similar like this, and I'm going to paste it here. And the only thing that I need to say is network 5555 with a mask of 32 bits. Okay, so and WR. So this part is done. Right now, router 2 and router 5 are in the same cluster. Now let's go to configuration of router 4 and 7. They are going to be in the same cluster as well, but the only client that they are going to have is router 6. They are going to be adjacent with router 2 and 5. So let's start on router 4. I'm going to say enable configure terminal router BGP to 100, no BGP default IPv4. Okay, I'm going to say BGP cluster IDs 47 47 47 47. Now let's say that I have neighbor 2222 in remote AS 100 with an update source of loopback 0. Also neighbor 5555 in remote AS 100 with the same update source. So update source is loopback 0. Now what I'm trying to say is network neighbor 6666 is going to be my route reflector client. So I'm gonna say in remote AS 100, and this is using update source of loopback 0, and also it should be my route reflector client. This should go under address family when you configure address family. So I go to address family IPv4 unicast. Neighbor 6666 is going to be a route reflector client, and it says that you should activate it first, so I'm going to activate it first. Okay, and route reflector client, and now I'm going to activate these as well, so they should be activated, and this one should be activated as well. So the only thing that I want to do is advertising a network. So this part of course is totally unnecessary. I'm just doing it. Okay, this part is done, and WR, and I'm going to say show run section router BGP, and the configuration on the other side is totally similar to this. So I'm going to just use this, and the only thing that on the other side doesn't have is this one. So I'm gonna use this part on router 7, en configure terminal, yes, have all of these And let's go back to router 4 and copy the rest of this without the network, of course. On router 7, I'm just pasting this. And under address family IPv4 unicast, I'm going to say network 7777. Okay, so let's save everything. Now the last router to configure is going to be router 6, which is a client to 4 and 7. So let's do this and then check everything. So I'm going to say go to configuration mode, router BGP 100, and no BGP default IPv4. I'm going to say neighbor 4444 is in remote AS 100 with an update source of loopback 0. Neighbor 7777 is in remote AS 100 with an update source of loopback 0. And then what I'm going to say is address family IPv4 unicast, and I'm gonna say this should be activated and this should be activated, and maybe a network 6666 with a mask of 255 255 255 255 is going to be advertised. So let's save everything, and after that what I'm going to say is for all routers I'm going to say show IPBGP summary, or with new format you can say show BGP IPv4 unicast. This is going to, of course, summary, because I wanted to show all the neighbors. You can say that show BGP IPv4 summary is the new format. So you can see that router 6 is neighbor with 7 and 4, which is okay. Router 7 is neighbor with 2, 5, and 6. 2, 5, and 6, which is okay. Router 4 should say the same thing. 2, 5, and 6, and you can see all of them are converged. Router 2 should be neighbor with 1, 3, 4, 7. Router 5 should be neighbor with 1, 3, 4, 7. Router 1 should be neighbor with 2 and 5 and 10, router 8. And router 3 should be 2 and 5 and 9. Okay, now I'm going to check the routes on all of these routers. So I'm going to say show BGP IPv4 unicast. And these R's, of course, say rip failure because I have advertised something that is already advertised into IGP as well. So I don't really care about that. I'm advertising this into BGP because I want to have reachability to other autonomous systems as well. So I have 1, 2, I don't have 3, I have 4, I have 5, I don't see 6, 7, 8, and 9, 10 are here. So I'm gonna check to see what the problem might be. So on router 3, I'm not seeing 3 show run. Section router BGP says that I have not advertised it into here, so no problem. Let's go to configuration mode, router BGP 100, router BGP 100. Address family IPv4 unicast, and I'm going to say network 3333 with a mask of 255 255 255 255. So end and WR, and the other thing that I didn't see was 1, 2, 3 is here, 4, 5, 6 is not there. I remember advertising 6. But let's see what is wrong with this. So show run section router BGP. I have said that 6666 should be advertised. So if I say show IP interface brief, I have 6666, and if I say show run interface loopback 0, so the mask is not correct. So I'm going to fix this because I want the loopback to be 32 bits in my case. So I'm going to change it to 32-bit, and this is going to fix the problem. So one more time, if I just go with show BGP IP for unicast, now I should see all the prefixes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are here. Okay, the other thing is I'm going to check something on router 6. I want to see what is going to happen when I check router 10's loopback. So I'm going to say on router 6, show BGP IP for unicast 10, 10, 10, 10, or you can say show IP BGP 10, 10, 10, 10. So you can see that I have received it from two different sources. Both of them, of course, are advertising the same exit point. I'm going to tell you why. The reason for this is we are on a route reflector configuration. Route reflectors do not advertise multiple base path by default. They advertise only one base path, and that is from their own point of view. One of the reasons that we say route reflectors have some intrinsic problems is we need to be very careful about what route reflector is advertising, specifically if you want to have offline route reflector. What I mean by offline route reflector is a route reflector which we do not really want it to be on the path of traffic. And most of the time, of course, you want the route reflector to be offline. But what we have is route reflector selects the best path based on its own metric to the destination, not based on my metric to destination. So we should be very careful with placement of route reflectors. In case we want to have multiple best paths, we can go with some configurations such as shadow route reflectors or add path, which is of course preferred. I have never seen a shadow route reflector implementation in production network. But add path is a very good idea, or having multiple route reflectors in different clusters. Here you can see that 2 and 5 are in the same cluster, so they are going to advertise only one base path. But if I had, for example, 5 in a different cluster, 2 in a different cluster, then each one of them would advertise another one. In case you have MPLS network, one of the ways to make sure the route reflector advertises multiple base paths is to use multiple route distinguishers for the same customer, and that is a practice which is done almost on every service provider that I have seen. Okay, so anyway, the route is received through cluster 25, 25, 25, 25, and after that 47, 47, 47, 47. I'm going to check this on all of these routers so that you can see the difference between what we see on router 6 and others. So router 6 sees this one. I expect router 4 and 7 to see the same thing. So if I go to router 4, I can see again exactly the same thing, but because it is not, it has received it from this cluster 25. Now router 7, of course, is going to see the same thing, because they are receiving this from the same cluster, which is this cluster 25. But let's go to router 2. Router 2 should see 2 exit paths. And router 5, of course, the same. So if I just go to router 2, you can see that router 2 says one of the exit paths is router 9, one of the exit paths is router 8. So I see 2 different exit paths here. The same result, of course, can be seen on router 5. But as you can see, they have selected that 10, 10, 18, 8, which is the route through router 1 to 8 is selected as best, and they are advertising only this one. That is why you see this on router 4 and router 8, and because router 4 is receiving it from 2 different routers but in the same cluster, you can see that it says 2 of them are advertising 10, 10, 18, 8 as the best exit path to get to the destination. So you see that route reflector acts as exactly like this, advertising only one best path. And like I said, I'm going to, of course, have another video on add path later, and you can see what is going to happen when you use that one, and of course some more videos, but right now we are just examining this one. And the final thing that I'm going to do is to go to router 6 and say ping 10, 10, 10, 10, and I'm going to use the source of my own loopback, so loopback 0, and the ping goes through without any problem. And if I just do a trace, you can see that because I have not, let me just disable this. This is going to take long because I really had to say no IP domain lookup and then do this trace so that I do not see so many waits for each one of them to be resolved. So you can see that it goes through router 7 or 4, and after that it goes to router 2 or just router 2, of course, and after that to router 1, and through that to router 8, and finally gets to the destination. Okay, so we have almost examined everything. We configured multiple clusters, and the reason for that was resource consumption. When you have so many routers as clients of one route reflector, as a matter of fact. But what we saw here was the suboptimal routing to the destination. And like I said, there are multiple solutions for that, which we are going to have in some later videos. And if you want to see these, subscribe to my channel so that you can have, and also click on that bell button so that you can receive notification whenever I just publish some new video. I hope this has been informative for every one of you, and see you in next videos.